So good morning all. Am I audible? Anybody from you? Is anybody from you? Am I audible? You are not audible. Anybody in the class? You may text the message in case if you are unable to speak. Okay, great. We got only four students now, and in the yesterday's lecture we have covered types of inheritance, in which we have started with single inheritance and the multiple inheritance. Let me recap what we have learned in the last lecture. So we have taken few examples where we have seen the single level inheritance, in which there is a parent class and there is a child class. There are methods that are written for both. The advantage of using the single level inheritance is that the child class can inherit the properties that are already present in the vehicle class, and few of the properties can be taken from the child class itself. So that adds features to the class, improvise the thing. The advantage of using it is that it improves the code reusability. The same code can be used again and again with new features added. So we have taken this example. We have also learned in the last lecture what is the method resolution order, that is MRO. Whenever Python executes this code, first thing it checks for the structure, then later it checks for the object. Once it finds the object, what it does is that it looks for the constructor. If constructor is not available, first thing it will look for the class, the name of the class, and after that it will look for the constructor. If constructor is available, then it will execute that constructor first, in which it will create the instance for the current object, and after that it will check for the methods that are written for that particular class. So in this particular example that we have seen, we have checked that whenever the code is executed, the Python looks for this object, my car, and the definition of that particular class, it will jump into this class, check for the constructor, whatever parameters are written in the constructor, it will execute. In this particular example, there is no parameter passed, so it will create a default constructor with the current instance for this object as self. Okay, and after that it will run the next line, that is mycar.move, and it will start looking for the function definition in the car class. So it will use method resolution order, MRO, in which the child class will have the first preference, the second preference will be given to vehicle, and after that the object. So it will look for this method. If this method is available in the child class, it will execute it. Otherwise, it will look for the method in the parent class. After that, it will execute this method, and then it will jump to the next line, that is mycar.playMusic. Again, it will look for the method in the child class first, and after that it will execute it. So this is an example of single level inheritance. After that, we have seen the example of multiple inheritance, in which a single child is derived from the two parents. So in the last lecture we have taken the example that how this particular class is executed. So Python again looks for the code, checks for the classes that are available, that is class engine, class radio, and a derived class from the two parents, car. The order is engine is the first parent, and the second parent is radio, and some methods are defined. There is no constructor function written here. So Python looks for the object, then the definition of the object in the class car. So it will jump and look for the constructor function in the class car. It is not available, so it will use the method resolution order, in which it will look for the constructor initialization function in the radio. If it is not available, then it will look in the engine. So in this case the order is like this: car to engine, engine to radio, like this. So initially it will look for the method instance or initialization function in the car. If it is not available, it will go to engine. In engine, if it is not available, it will go to radio. So once it does it, what it will do, if it is not available, it will create a default constructor with a instance for the current object. It will allocate the memory to it with the name self, and after that it will execute the next line. So mycar dot start engine. So it will look the definition of this method in the current class, that is car. If it is not available, it will look for the definition in the engine. It will follow the MRO, correct? So here the definition is provided. It will execute this line and again it will come back from this line to the next line. So again it will look for this method in the car class and after that it is going to execute it one by one. So in this particular case, what we observe that the MRO plays a critical role in the case of the execution of the code, in which the Python looks for the code according to the precedence that is provided by the method resolution order. So another good example that is provided for the multiple inheritance is that what will happen in case if the two methods written in the parent are same. So there is a possibility that the parent might have the same method with the same name, but it serves two different purpose. So for example, class engine with a method defined start, it will print the message engine starting, and second method radio, in which the same method name is there but the message that is available is radio turning on. After that, a derived class car, the MRO is engine first parent and radio is the second parent. So when this code is executed, Python will come to know that there are total two parent classes and one single car class which is derived from first parent engine, second parent radio. It will look for the object. Once it finds the object, it will create current instance for this object and look for the constructor in the car class. It will look for the constructor, it is not available, so it is going to look for the constructor initialization function in engine. If it is not available, it will look for in radio. In all the cases it is not available, so it will create default instance for the current object in the memory and it will run the next line, that is pass. Since nothing is available here, it will execute the next line, mycar dot start. Again it will look for the method in the car class. If it is not available, it will look in the engine class, correct? Since both the methods are having the same name and the precedence by the method resolution operator is higher to engine, it is only going to execute the method that is given in the engine class. So it will not execute this method. If you want to execute it separately, you will have to call it like this, engine.start mycar. So it will execute the method that is available in the engine class, and when you type the class name dot start mycar, it will execute the method that is provided in the radio class. Another important thing in the Python is the mention of super function, which is also used for resolving which is used for resolving the precedence in case if there are multiple constructor declared or multiple methods declared with the same name. So in this particular example, we can observe that there is a class engine which is a parent class, then there is a class radio, then there is a class car which is derived from engine and radio. So there are two parents available, and then we are having the function super. So what is happening in this particular program is that there are three constructor and the definition of constructor are different in this case. So in order to resolve which constructor should be looked by the Python code, I can resolve it by using the mention of super function. So whenever I put a super dot, the name of the function or name of the constructor, it will only execute the constructor according to the MRO. Okay, depending on the MRO, whatever is the precedence, the first constructor will be executed according to it. So for example, if I write car engine radio, in this case the MRO will be car will be the first class, engine will be the second class, radio will be the third class, and after that the object. So if I write here super dot initialization, the constructor, whenever the code is executed, once it sees the definition of the child class, it will look for the constructor. In the constructor, the second line is init, that is the constructor in which the definition of the current instance of object is available. So it will check the MRO precedence. It is engine first, so it will check the definition of the constructor here in the engine class. It will jump here, create the current instance of the object, and it will execute this line, and you are going to get the output that is printed as engine init. Okay, it will not execute this constructor. So whenever I declare super, the MRO will be the prime focus. According to the MRO order, it will look for the definition of the constructor function according to the precedence that is given in the constructor. So the next type of inheritance is known as multi-level inheritance, in which you are having a grandparent or a grandparent class or a grandfather class and the parent class. Then you are also having the child class. So in this particular case, the hierarchy is like this: grandfather is the base class, parent is the derived class from the grandfather, child is the derived class from parent. So there are methods that are written here. You need to check. The first thing is the default constructor or the constructor that is declared in the vehicle class. After that, the child class or the derived class from the vehicle. Again, there is a constructor with two attributes, brand and model. So brand is derived from the grandfather and model is the new attribute that is added in this particular class. After that, you are having the second derived class, that is sports car, which is derived from the class car. Again, it is having the constructor with the parameter brand, which is derived from the first base class, and the second attribute, that is model, that is derived from the car class, and the third attribute, that is the top speed, which is the new parameter or the attribute added in the child class. Again, the definition super, and second method that is written for the sport class is race mode self. So I'm going to print the brand, the model is race mode, and top speed is this much. So again, the object, the name of the object is Ferrari, and the name of the class in which the parameters has to be passed are sports car. So when this code is executed, Python comes to know that there are three classes. the first class is the base class, the second class is the derived class from the base class, and the third class is the derived class for which the car is the base class. After that it jumps for the check the object. So it will check that the object is there, and the class in which the parameters has to be looked is for the sports car. So it will check the definition in the class. So it will look for the default constructor. So it will jump here. It will see the constructor definition here. It will create the instance for the current object, allocate certain memory to it. It will check for the attributes brand, model, top speed. Then it will jump to the next line. It will see that there is a function that is super. So it will again look for the MRO, that is the meter resolution order. So in which the sports car is having the first priority, second, and the vehicle is having the third priority, because the sports car is derived from car and car is derived from vehicle. So once it looks for the super, it will jump for checking the constructor in the vehicle class. So it will move from here to here. So it will jump to the car class. Again it will check the constructor definition that is provided in the car class. After that it will check and again create the proxy object for the proxy instance for the current object with the name self and the two attributes, that is brand and model. After that it will go to the next line. Again it will see that there is a function that is super declared here. So again it will look for the constructor that is available in the according to the MRO in the vehicle class. So it will jump here. Again it will look for the constructor definition. So there is a parameter self. So again it will allocate temporary memory to it and the parameter brand. So it will allocate the memory to it, and then it will look for the parameter Ferrari that will be allocated to this brand. So self gets certain memory, that is current instance of the object, brand gets Ferrari, and this brand gets assigned to self.brand. Once this line is executed, it will jump from here to this line, okay, in which it will check self.model and the parameter is model. So model will get allocated to F8, and the proxy memory that is allocated for the self will now be tagged with the attribute self.model is equal to model, so that self.model becomes F8. After that it will jump to this level self.topSpeed, correct, and in that case it will allocate 340 to this top speed, and the proxy current instance of the object that is created will be tagged with the value that is equal to the top speed. After that it will execute the next line, that is the Ferrari dot race mode. Again the definition, it will look inside the sports car. The method is defined here, so it is going to execute this line. So Ferrari F8 in race mode, top speed is equal to 340. So one needs to remember that whenever multi-level inheritance is used, the first thing you need to check is for the MRO, the method resolution order, which class is having the first preference. second preference and the third preference. Whenever the super function is used, it is used for passing the constructor function in the class according to the MRO precedence. It will look for the definition of the construction function in the list provided by MRO. If it is not available, it will jump to the next level. The last type of inheritance is known as hierarchical inheritance. So in the hierarchical inheritance, you are having a single parent and multiple childrens, and the multiple childrens inherit the property from a single parent. So let us take a example here. So we are having the parent class vehicle with a constructor that is coming with the attribute brand. The method that is declared is fuel type. Then we are having the first child class, that is class car, which is derived from the class vehicle, with the new method that is added in this class is wheels. Then we are having one more child class which is again derived from the vehicle, and the new method that is added is wheels. Third, truck, and after that the declaration of the object. So when this code is executed in Python, what Python sees is that there are total 4 classes declared. One of them is parent, the remaining 3 of them are child. It will look for the object, it will check for the name of object car, and the parameters that are passed for the class car. So it will jump to the class car, correct? So it will jump from here to here and look for the constructor. Constructor is not declared here, so it will look for the constructor according to the MRO to the parent class. So it will look for the constructor here. So it will check that the constructor is declared here. So first thing it will do, it will allocate certain memory for this current instance of the object self, and then the attribute will be allocated with the name Toyota. After that, it will be assigned and tagged with the current instance of the object, that is self and brand. So self dot brand will become Toyota now. It will jump to the next line. After that, the second object is bike, which belongs to the class motorcycle. So it will jump to the class motorcycle. Again look for the constructor. If it is not available here, it will jump here, and what it will do, again it will create the second instance for the object and allocate Harley to the brand. In this case, it will become brand is equal to Harley for the class motorcycle. Okay, and whenever you are going to call for the functions or methods like car.fuel type, it will check for this function in the child class first, that is car. Whatever method is available here, the fuel type method is not written here, so it will jump here and it will print the value uses fuel. The brand is Toyota and uses fuel, like that. So another important thing in the case of Python programming is that we can protect the methods that are declared inside the class by using access modifiers. just like what we do in the case of the C language, by simply instead of writing public, private or protected, Python provides the advantage that the class attributes or whatever methods are there, these methods can be declared by simply placing the underscore. So if I want to declare something as a public, no need to use the underscore. If I want to restrict the use of the particular attribute within the class or the method within the class, I can simply protect it by putting the underscore, single underscore. So the particular attribute or the method will be only accessible within the class. It cannot be accessed outside the class. However, it can be accessed in the derived class. The third important attribute, which is known as access modifier, which is known as private. If I want to keep the attribute or the methods private, which can be only accessed within the class, in this case I need to declare that particular attribute or the method by using 2 times underscore. Okay, so one of the advantage of Python considering the C++, we don't have to write private, protected or public in the program. Instead of that, whatever I want to make public, don't put any underscore in front of that particular attribute or method. Or if you want to protect something, you need to put single underscore either in the case of attribute or either in the case of method. Okay,